Thanks everyone for joining and everyone online for listening in. So first up, we're going to have Maddie Kennedy talk. She is a 2017 Knauss Fellow at the National Sea Grant Office as a coastal resilient analyst. She graduated from the University of South Alabama with a master's in marine science. And Maddie enjoys long walks through the forest and on the beach with her dog.
Hi everyone. This is going to be my dissertation for my work down at the Sea Lab. I did this work in collaboration with Dr. Ken Heck as well as Dr. Tommy Michaud. I'm going to be talking about the impacts of wintering redhead waterfowl on seagrasses of the northern Gulf of Mexico. So as many of you guys know, seagrasses are considered one of our high-value ecosystems. They're known as the most productive and diverse near-coastal ecosystems that we have. They're a large source of primary production, and they act as foraging grounds for large vertebrates and invertebrate species, and in the Gulf of Mexico, this is really critical. They also act as nursery grounds for economically important finfish and shellfish, such as snapper as well as blue crabs. They're also a major form of carbon sequestration. It's thought that about 10% of all sediment sequestered carbon is actually found in seagrass beds along our coastlines, as well as major sediment stabilization for nearshore habitats. Unfortunately, these ecosystems are undergoing increasing threats. Some of these threats include coastal development, which can lead to nutrient pollution, increased runoff, as well as mechanical damage from watercrafts, as well as threats from our changing climates. Increasing water temperatures are rising beyond their thermal tolerance, which is causing stress on a lot of species, as well as the poleward range expansion of many tropical herbivores, which primarily feed on seagrasses. So one of the lesser known threats that we talk about is the impacts of grazing, especially in warm temperate waters on tropical seagrasses. These vital ecosystems, the direct grazing can actually impact their health and sustainability. So there's several different species that graze directly on seagrasses. The first of these is parrotfish. In 2002, Kirsch et al. Showed that parrotfish can actually consume 85% of the above ground biomass of seagrass. While this is a large number of parrotfish, this study showed that there was no negative impacts on seagrasses. Another species that is one of our largest grazers are urchins. And I have two studies that looked at this, the first being Heck and Valentine in 1995. And they showed that seagrasses can be locally overgrazed by sea urchins. And then again in 1997, Valentine et al. Showed that at intermediate intensities, urchin grazing can actually increase the amount of biomass that you have in seagrasses. Another one of these large grazers, and actually our largest grazers, are the sirenians or dugongs and manatees. And a study by DeZanza et al. In 2015 showed that manatees can cause significant impacts because they uproot the entire seagrass bed, and they can actually reduce the amount of biomass by 50% in these seagrass beds. Another grazer, possibly one of my favorites, are turtles. And a study by Forker et al. In 2010 showed that turtle grazing can actually change the structure of a seagrass meadow, such as the height and the flowering trends of seagrass beds. Today I'm going to talk about one of the lesser known waterfowl grazers. These are waterfowls. Waterfowl are one of our dominant grazers, especially in temperate zones. And the Gulf of Mexico, so where I did my study down here, is one of the most important winter waterfowl grazing areas in the continental U.S. The species that I'm going to be specifically talking about are redheads, and it's estimated that 80% of their population winters in this ground every year. The effects of winter waterfowl grazing are really understudied. There's been a lot of studies of waterfowl grazing, but only 3 on what the effects of grazing do to seagrass. So what we do know about redheads as grazers, redheads appear to selectively feed on the below ground biomass, which is a little bit unique for a typical grazer because this is the energy store of the seagrass. It's also the hardest part to get to. Redhead grazing has been shown to reduce shoalgrass rhizomes between 26 and 33%. Another study showed that areas heavily grazed by redhead below ground biomass loss was significant, more significant than in areas with less grazing. And then also another study showed that as much as 84% of redhead gut content is actually shoal grass or Haliduli radii. So the rationale behind my project, because of these very few studies, we were really curious at what was going to happen. Most of the studies that were down in the southern Gulf of Mexico, so down in the Laguna Madre or the Chandeleurs. Those of you guys who don't know, Laguna Madre is basically the Texas-Mexico border. And so these studies are a little bit different than previous grazing studies because of the way that birds graze on seagrass. So we were expecting some significant results because the entire energy store of seagrass is being removed. This was the first study of redheads in the north central Gulf of Mexico. So from Mississippi all the way through the Florida Panhandle, there had never been any studies on redheads. And so we were sort of hoping to set a baseline for future research, especially in the face of changing climates and increasing anthropogenic impacts that may be shifting where the redheads are going to be wintering. So my three objectives were first to measure redhead winter grazing rates in the northern Gulf of Mexico, examine the effects of redhead grazing on the recovery of biomass during and following the grazing season, and finally to confirm that shoal grass and widgeon grass roots and rhizomes were the primary food source of waterfowl in this area. So this is my study site, just to orient everybody. This is Alabama, Mississippi, here's Mobile Bay, much bigger. This is Dolphin Island, where the Dolphin Island Sea Lab is located. And I had three study sites, one to the east over here at Point of Pines, and this site is a very underdeveloped sort of habitat. The only really anthropogenic influences in this area are hunters, especially during the winter. And then I had two sites over here, Rabbit Island and Ono Island. This, for those of you guys who have ever heard of the Floribama is literally right there. And this site was a little bit different because it was in a much more densely populated area with high boat traffic in this area, although there was very limited hunting in this region. Both these sites were chosen because there's ample grass beds. It's really hard to tell in this picture, but this dark area over here in Rabbit Island and by Ono Island, that's all grass. And I had also had previous reports of seagrass in this area. So at each of these sites, this is my study design. I had 3 control cages and 3 exclusion cages. This is what an exclusion cage looked like. It was made out of PVC and bird mesh. It was 2.25 meters squared, and the bird mesh came all the way down to the ground to limit grazing because the ducks actually will dive up underneath a cage to get into the grass on the inside. These cages were placed sporadically 5 meters apart within the seagrass bed where available, and I had anywhere between 1 and 3 groupings of this setup depending on how much seagrass I had at each of the sites. So to sample the seagrass, I went out in the field 5 times throughout the year. Before birds came, so that was in about November, mid-bird grazing and following grazing, which was usually in April, and then I also did in peak summer, which was during their peak reproduction time, and then again in fall, which was at peak growth. I took these cores. They were 7.3 centimeters in diameter, and I took them down to about 10 centimeters. I brought the cores back to the lab, froze them for later processing. When I processed them, I separated them by species as well as above and below ground biomass, and I measured the dry weights of both. So these are the 2 species that I was getting. I got widgeon grass or Rupia maritima and shoal grass or Haliduli radii. So for statistical analysis, I ran a really simple Bakke analysis. For those of you guys who don't know what that is, it's a before-after control impact. And this is really important because it assesses if and how of the effects of a given condition. So my effect would be the grazing, and the impact would be how much grass is left following the event. The advantages of this type of analysis was that sampling was able to occur before the impact and then after the impact, and it takes into account any existing differences between the exclusion cages and the control cages. So that means that any differences that I do find can be attributed directly to the impacts of grazing. So what I did was I calculated the mean differences between grazed and ungrazed plots, as well as above and below ground biomass for pre and post grazing time periods. I carried out 2 simple t-tests on the means of the pre and post grazing and found the difference in the grazed and the ungrazed plots. If I didn't get any significance, that suggested no impact of grazing. So the next thing that I did was to look at the waterfowl abundance, and how I did this was I set out game cams at each of the different sites, and these game cams are programmed to take a picture every 5 seconds during daylight hours. And this was an example of what each of those different sites look like. So this one up here on the upper right is over at Ono Island. This one over here on the upper left is from Point of Pines, and then this one down here on the bottom is from Rabbit Island. And each of these is an example of what it looked like when the sites had birds. So these are all redheads in each one of these pictures. So because of the way that the cameras were set up, I got over 4 million photos. And for my own sanity, I set up a sort of a validation of the way that I was going to count these. So I ran a 2-way ANOVA, and I counted. It was comparing either counting every single photo in each minute, so that was about 6 or 8 photos depending on the minute, versus every 3 photos per minute, and then all minutes when ducks were present versus every 10th minute while ducks were present. And so I ran a 2-way ANOVA, and because I got a lack of significance, I was able to count only 3 photos per minute every 10th minute, which saved my sanity in grad school. So this is what each picture looked like. This is an example. For your reference, these are the cages that I had out. These are the exclusion cages. Each one of these little dots is a bird, and I've circled the animal or the waterfowl that are feeding. And I could tell this because they stick their little duck butts up in the air, and like it's pretty obvious when they're feeding. And then these ones are the ones that are resting, the ones indicated by an arrow. So what I first did was I went through, and I played all of these as a video, and so I got to sit here and watch like ducks swim around, and this is what it looked like on a pretty constant basis. So I had 4 million of these tiny little pictures to count, but you can see that they're pretty actively going in and out of my study site and in between the cages. All right, so sorry, this is a little graphic. This is the last thing that I did to verify the gut content and the feeding habits of these birds. Ducks were opportunistically collected because I cannot hunt, because I'm very bad at it. And so they were given to me from hunters and guides in both Point of Pines and Perdido. The gut content of the digestive system above the stomach was analyzed for the type of seagrass that was found within them. And so this was me getting I learned off of YouTube how to do this. And then I would pull out the different species and the above and below ground biomass and weigh them, or dry them and weigh them. So moving on to the results. First, I wanted to start with any study that includes growing and seagrass and cages. One of the concerns is the light availability. So just to ease everyone's concerns about this, I did test the photosynthetically active radiation, or PAR, during my 3 sampling times when the cages were deployed. And what I found was that light was universally limited in only the spring session, or only the spring sampling, and that was both inside and outside of the cages. And at that time I removed the cages and we were going into the growing season, so I don't think that light limitation had any influence on seagrass growing during this study. So going on to duck activity, this was based off my cameras, and what I have here is a chart for you showing the percent of days that birds were present at each site. So on the top is year 1 and on the bottom is year 2. I do want to point out one thing that I did not see on my cameras, a bird at Ono Island during the 2nd year, and this was because my camera died. So I had some issues, technological issues there. But in both years, I had the most days with birds feeding at Point of Pines, which did not surprise us because it was an uninhabited area, so the ducks were a little bit more free to roam around. And then as far as the percent of birds feeding, so looking at their activity, the highest percentage I had was in year 1. I had 33% of the flock feeding at any given time, and this was over at Point of Pines. Again, not surprising because this was a more available area for them to graze. It was a more relaxed habitat, if you will. So to conclude about duck activities, redheads frequented all of my sites during the winter season. As much as 33% of our flock was grazing at any given time. And then compared to some of the other study sites, so like down in Laguna Madre or over in the Chandeleurs, we had much smaller flock sizes. Over there, they were getting like 300,000. I was getting 100. So this might have some implications later on in my results. So moving on to the seagrass data, the next several slides are all going to look pretty similar to this. I'm going to orient you because they're a little confusing. So on the bottom, I have my sampling date, and these gray bars represent when ducks are present. So this is their feeding time. So this is basically representing winter. This is summer, winter, summer. I then have the dry weight in grams per meter squared on the vertical axis. I have in dark circles is our ungrazed biomass. In open circles is grazed biomass. The top graph is always going to be above ground material, and the bottom graph is always going to be below ground material. So I'm going to start off with widgeon grass because it's really not exciting. This is all the data from all the sites pulled into one graph. And what I want to point out is that we had this crazy decrease in the amount of biomass in the second year for widgeon grass. But we also saw no trends or no real differences. Like, yes, there's a difference here, but there's no real differences in the amount of biomass that we had in widgeon grass. And for that reason, I'm not going to talk about widgeon grass again in this presentation. There were no significant differences in the Bakke analysis, which, again, I'm not going to keep talking about widgeon grass. So now moving on to shoal grass or Halogili radii. Again, we have above ground biomass, below ground biomass. What I want to say for all the sites pulled together, we did see this general trend and increase in the amount of grass, which is totally what we should expect in the summer and fall months. We should have more biomass than we have in the winter. But I do want to point out that overall, we had more biomass in the ungrazed cages, both for above and below ground biomass. Unfortunately, this was not determined significant by my Bakke analysis, but I still think it's cool. So then I'm going to move on to the more specific location-based stuff. So starting with Rabbit Island, again, we see this significant or this trend in the amount of biomass in the summer and fall months. We didn't see any significant differences between grazing pre and post with either above or below ground at Rabbit Island. At Ono Island, we see some of the same trends with an increase in the amount of biomass, especially in the above ground. And then in the below ground, I want to point out something that's a little bit unique. We had this strange delay in the recovery of below ground biomass, and we think that's because when the birds are removing the roots, it's making it much harder for our seagrasses to reproduce, because in the northern Gulf, they don't reproduce by seed, they reproduce by root propagation. We only saw one significant difference, and that was in the below ground biomass following in the second year post grazing. And then finally, over at Point of Pines, again, this was the location with the most birds and the most feeding activity. So we did see the same general trends of an increase of biomass during the fall and summer months, or the summer and fall months. And we saw two significant differences in the pre and post biomass, and they were both for the above ground, and they were both immediately following. We had significantly more biomass in the ungrazed locations than we did in the grazed locations. So to conclude about biomass, I know that was a lot of information. For widgeon grass, we didn't see any significant relationships between grazing and biomass, and the biomass just decreased in general across all the sites. For shoalgrass, uncaged areas had more biomass especially after the second season, suggesting that grazing limits the amount of growth. However, we don't think we captured the full effects of grazing because this was only a 2-year study, and we think that the effects of grazing may take longer than 2 years. The results that I got are really similar to the 3 previous studies that were done before. Both Cornelius and James showed that there was little effect of grazing on seagrass. And then we also showed that, similar to Mitchell et al. In 1994, that redheads could potentially reduce the biomass following major grazing events. So getting into the gut content, this will be really quick, but of the 92 birds that I surveyed, I only had 4 that had actually anything in their stomach, which sort of shows just how hard it is to collect a bird that has been eating. They estimate that it only takes 4 minutes for a piece of grass to be fully digested and unrecognizable in a bird, so you basically have to shoot it while it's eating, which is super illegal. So I'm glad that my hunters were following the law, but for my science it was a little bit hard. I did find that all the birds did have shoalgrass in their esophagus that I could easily identify, and all of them did have below ground biomass, which is similar to what previous studies were showing. So to go back to my objectives and give you my conclusions, my first objective, measure redhead winter grazing rates. Up to 33% of redheads are grazing at any given time. To look at the effects of redhead grazing. In the short term, there are very few effects, or we feel that there are very few effects. However, long-term effects may be more present, and as more birds come up into the northern Gulf of Mexico, as it gets too hot down in Texas for them during the winter, this may also have some sort of impact. Also, current rates of grazing seem to be pretty sustainable for this region. And then finally, I did confirm that the food source of these birds is mostly shoalgrass. So some future implications. This study provides a baseline. I know that it will be used to justify during bird counts, as well as some other projects in Alabama, because right now Alabama and Mississippi are just skipped when they do the winter bird counts because we don't know why. And then with changing climates and increasing anthropogenic impacts, this could have future implications on both seagrass populations and waterfowl populations in the Gulf of Mexico. With that, I'm going to thank everyone who helped me, mostly the HEC lab down at the Dauphin Island Sea Lab, a plethora of interns, as well as a very patient hunting team that just like to laugh at me a lot. So with that, I'll take any questions. No questions?
I have a fairly simple question. How did you get the hunters to like give you their birds?
Yeah, that was a really good question. So it started off really rocky. I got a couple guns pointed at me and then people telling me that I was trying to take all their birds away and I was just a scientist. But eventually I convinced them that I was actually trying to bring back birds to the region. So they were calling me and being like, hey, I have birds. And I would just sit at the dock and give them the breast meat and take their carcass. So it was sort of an easy way for them to get rid of the stuff they didn't want to use. Yeah.
Did you do all your counts manually?
For like, what do you mean?
The image count?
Yes. I couldn't beg undergrads to help me, so I just did it myself.
Did you try an image analysis?
Yeah, so we tried an image analysis software, but the problem is that all the codes that are out there would recognize like a wave peak as a new bird. So I couldn't use, like, it wasn't distinct enough between, and a lot of the days since it was winter, we were getting these pretty stiff storms coming through, so we had some pretty high wave activity. So we never successfully, we tried, we wrote like 3 or 4 codes, but it didn't work. My eyes were like bleeding for 3 months. Yes. Yes. I ultimately don't, I knew the number, but you would have had to ask me a year and a half ago for that number. But I know that if I had sat there and counted every photo, it would have been like 4 million at least. I crashed the server like 12 times. It was really good. Any other questions? Yeah.
I'm really sorry I was late. So I'm sorry.
No, you're fine.
But you said some sites
like yours had about 100 birds in flock, but other places like 300,000.
Yeah, so Laguna Madre is down on the Texas Mexico border, and it's the #1 wintering habitat for waterfowl, and probably like all of the birds that come in through the Mississippi Flyway, all the ones that come on the Eastern Flyway, all end up in Laguna Madre. And it's really unique because they have just like mile-long grass beds that can support these massive flocks of birds. But we don't, in the Gulf of Mexico, it's still a little cold, and mostly because our grass dies during the winter, whereas down in Laguna Madre, they have a year-long growing season for the most part.
I was just wondering if your site had historically seen as birds as we haven't, or it's just
So historically, we had much larger flocks of birds, but hunting pressure became pretty serious in our region. Again, it's really hard to know because, so these numbers are all collected by Fish and Wildlife and the National Park Service in their winter waterfowl counts, and they basically do massive flyovers of all the national parks lands. Because we don't have national parks, they don't do those counts for us, even though we have like 20 miles of shoreline, so it takes 5 seconds. But historically, and a lot of the conversations that I had with really old hunters, they said that back when they were kids, they would get like flocks of 1,000, but we just don't see those numbers anymore.
what's the historic range of
They're still in their historic range. It's just their overall numbers are diminished, like their flock sizes. They have in like the last 5 years, the overall population of redheads is increasing, but not to the levels that it used to be. Are there any questions on the internet? Okay. Any other questions?